Okay, so it's time to talk about the answers to the pregame stretch. And today in the first video, we're going to do pregame stretch and review. And then in the second video, we will do the new stuff for today. All right, so I don't know why it says Math 1000 up there. It should say Math 1180. It's probably an old mistake that I haven't corrected yet. First was to evaluate each of the following. So look, there's not a lot of give and take here, but I will point out potential mistakes. Things that I put in these. I intentionally try to make sure that at least once a day we see a negative number with an exponent so that you realize you have to put it in parentheses if you are putting it into the calculator, because the parentheses to a calculator means square -8. If you don't use them, use the parentheses, it means square 8, then negate it. I also did the same thing in number 2. So there's the correct answers there. Number 3, from goes first. Number 4, last shall be first, first shall be last. Numbers 5, 6, and 7. Again, you can look these all over at your own pace. I'm just trying to bring up the important points that I find in here. Remember, if the arrow points to infinity, it's all infinity, whether positive or negative, is always a parenthesis, because you cannot equal infinity. Always a reason for things in math. Nothing's ever random. Business as usual over here in the other ones, typical steps. Number 7, is 10 a solution? No, because the solutions are from negative infinity to -10. That is to say, less than or equal to -10. And 10 is not less than or equal to -10. Number 8, I divide both sides by h, multiply both sides by 2, and then subtract the b sub 1. Number 9, this is a little bit new. We also have one today like this in today's slideshow. Solving for doing a literal equation, but this time with the squared exponent. So I got to get b by itself, subtracting a squared, and then I have to square root, because that's how I do the inverse or undo squaring. So b is the square root of c squared minus a squared. And then number 10. Pretty straightforward. You see the x's are over the x's, the y's over the y's, numbers over numbers. That means we go elimination technique. I love the fact that these signs are opposite in the middle. That means all I got to do is multiply the top by 5. Remember, you take the coefficient in front of the variable you're looking to get rid of in the second line, put it up top, and then reverse that on. You take the variable from the first equation, put it on the second line, and that will make sure that you wipe them out with -10y's and +10y's. X works out to be 3, and then substituting it back in, y works out to be 1. Again, you can take as long as you want to look through these answers just by doing stop and start, see what my steps are. And as always, if you do not follow along with what I did, feel free to, if you don't follow along with what I did, feel free to reach out to me in an email. All right. So we are done with that. Now it's time to start the slideshow for today. You should be getting the big slides now. That problem that occurred that one day doesn't seem to have occurred since. Today, the new stuff is all about laws of exponents. That's our topic of the day. But before then, we have to look at our agenda. And our agenda will be that we review the homework. Well, we had a test last week, or last lesson, I should say. So there will be no homework to review. I may well have, for regular class, excuse me for the yawns. I don't know why I'm yawning. For regular class, I might well look at what the 2, 3, 4 most common mistakes are and discuss them in regular class. But I'm actually making this video before you take the test, because I'm going to be away and I have to make sure that this is ready to go on Wednesday morning, and I will not be getting back until Tuesday night. Okay. The pregame stretch we just went over. We also obviously must have completed it in order to go over it. And then the recent recap, the recent work recap. And again, I might mention some takes on the test at that point in time too, if I see anything in the recent work that reminds me of things that we needed to get better at from the test. And then the new topic of the day, laws of exponents. Okay, some things are such critical skills that I tend to like to go over them every day. Go ahead. Do these two. You know the drill about stop and start, so I can get going right away on what these answers are in another couple of seconds. As soon as I have my sip of BAI. By the way, if you drink BAI, as I do, I cut it with water. I do more or less 3 parts water to 1 part, I call it by. And it's too sweet for me if I don't do it that way. But with this, it works out perfectly. So if you haven't tried it, you may want to try it. Some ice, cut it with about 3 parts water. And that includes the ice. And I think you'll be in good shape. Okay, so I look at this first one. And I see same size, same operation. I don't know why I'm yawning so much. Well, this is a little bit strange. I'm going to take a moment to fix this. This is 12H. This is 9H. How did I ever come up with 5H out of that, or whatever I had before? Right? 4 and 1 is 5 and 7 is 12. I don't know how I came up with that. 9H minus 20 is 22, adding, so this would be a 9. A 9 and a 9. And 42 over 9 is going to go in there. 4 and 2/3. Right, because 9 times 4 is 36, and there's 6 9s left over. So 4 and 2/3. All right, so let's get back to where we're at. Play from current slide. How a trained professional handles an emergency situation. So, as done correctly this time, 4 H's and 1 H make 5 H, and 7 more H's make 12 H's. Minus 20 is 3 H plus 22. Opposite side, opposite operation with the minus 3 H's. Always start with the smallest H's. And then 9H minus 20, add the 20. It doesn't go in evenly this time. I divide by 9, and 9 goes into 42 4 whole times, and 2 parts out of 3, or 2/3 is left over. It's actually 6/9, but 6/9 reduces to 2/3. Okay, next up, distribute both sides. 12K minus 15 is 2K plus 50. Subtracting 2K from both sides, 10K minus 15 is 50, adding 15. 10K is 65, dividing by 10, and K works out to be 6.5. You may wonder why I used a fraction in the first one and why I used a decimal in the second. I could have written 6 1/2 in the second one. That would have been just as easy. But in the first one, if you write 4.6 or even 4.7, you would be wrong, because you would be rounding off, and the problem didn't tell you to round off. So you'd be really close to right, but sorry to say, you would not be right. So unless it tells you to round off, or unless your decimal terminates, write it as a fraction. That's the way to go. Procedure for solving linear equations, just a quick review here. Is it same side or opposite side? Same side, same operation. Opposite side, opposite operation. Work toward a standard two-stepper, and then then you're going to isolate that variable, figure out the solving, and if it asks you to, then you check it. Okay, let's have you try this one. And this time I did distribute. Oh man, I made another mistake on this one. I wrote the wrong number in there. 14, all right, so you're going to do pause, stop, and start. I'm going to click this up, and let's see if this works okay. No, it doesn't. So I have to go to, I did this afternoon too. I didn't even do this late at night. This should work out to be 14N. That should be 7N, which would make this 5N. Had it worked out great for an 8, right? This decimal does terminate, so we're good. All right, we'll play from current slide. Other than the fact that my allergies are really bothering me today. All right, so We distribute the 4 and the 2. That gives me 12n minus 28 plus 2n plus 14 minus... Oh, I see what I did. See, I changed it in the top and I didn't change it in the bottom. Let me go back. I had it right. This should be 12, 14, 10. So I did have it right the first time. Oh, look at that. My big mistake was not changing that. Clearly I copied it from an older problem. So I did have it right the first time. And let's go through it. Okay, so 4 distributed to 3n minus 7 is 12n minus 28. 2 distributed is 2n plus 14 minus the 4n. I had copied it wrong and put a 7n. That was why I was a little off base there. 2n plus 18. On the left, I see a same side, same operation situation. That is to say, combine the like terms. That's 14 n's, right? 12 n's plus 2 n's make 14 n's. Minus 4n makes 10n. And negative 28 and positive 14 makes negative 14. Equals 2n plus 18. Always start with that smallest number of n's. Subtracting 2 n's, I get 8n minus 14 is 18. Add 14. 8n is 32. Divide. N is 4. Okay. Oh, here we go. Some literal equations here for you to do. Solve them both. In both problems, solve for A. And then we'll go through them together. Go ahead. Okay, so first problem, solve for A means get A all by itself. I subtract the 15b from both sides, and then I divide by 5. I did this because I wanted it to be something like a y equals mx plus b problem to give you a little practice on that. Okay, 5 divided by 5 is 1, 10 divided by 5 is 2, so I get, oh, that's supposed to be an equals, not a minus sign. That should be A equals 2y minus 3b. The minus sign is right next to the equal sign on the keyboard, and I am a lousy typist. So A equals 2y minus 3b. Next one, solve for A. Get A by itself. So I subtract the b squared, and I get A squared equals c squared minus b squared. We have not done many like this. So to invert or do the opposite of or undo squaring is to square root. So I square root both sides, and the square root of A squared is just A. So I get A equals the square root of c squared minus b squared. Okay. Next up, 3 inequalities to do. Go ahead. Okay, so on the first one, I subtract 11. Negative 3n is less than 6. Then I divide by negative 3. And I get n is greater than negative 2. Remember, if you multiply or divide by a negative, you have to switch the direction of the inequality. Since it's greater than negative 2, open circle at negative 2. It's not allowed to equal it, so we don't fill it in. And then arrow going to the right. Next one up. Distribute the negative 5. Negative 15x plus 35 minus 2x plus 3 is less than or equal to 7x plus 50. Combining like terms, negative 17x plus 38 is less than or equal to 7x plus 50. A few different ways we can go with this, but I would normally like to get rid of the smaller number of x's, so I'm going to add 17x to both sides. That gives me 38 is less than or equal to 24x plus 50. And then I subtract 50 from both sides. And then I get negative 12 is less than or equal to 24x. Divide by 24. And I get negative 1/2 is less than or equal to x. But for graphing purposes, we always want the x on the right. And remember, if we switch sides, if it points to the negative 0.5 here, it's got to point to the negative 0.5 there. There's my negative 0.5. This time I fill the circle in. I take the one with the arrows on the left, so I go to the right as it's greater than. Okay? And then in our third question, we subtract 5 from both sides. Multiply both sides by negative 4. Since I multiplied by a negative, I've got to switch the direction of the inequality. Remember, I don't care if I go into a negative. That's irrelevant. Right? In the previous problem, I did not switch on the step where I divided into a negative. That's irrelevant. And likewise here, I'm multiplying by a negative. Now I switch. Okay, so x is greater than negative 20. Open circle at negative 20, arrow to the right. If I look at this, before we answer about bracket notation, if I look at the first one, negative 2 is not a solution because it's not or equal to. On the second one, negative 1/2 is a solution because it is or equal to. And you could tell, like if the circle's filled in, it is a solution. If the circle's not filled in, it's not. And for negative 20, it is not a solution because it's not filled in, and the arrow, there is no or equal to underneath. Okay, let's express each of those three in bracket notation. So let's do that. I'll give you a minute or so. Well, your time. You can start it whenever you're ready. Okay, so for the first one, the smallest value is negative 2 on the left, and you go out to infinity. Remember, you can't equal it, so it's parentheses. Next one, you can equal, so it's a bracket at negative 0.5, and you go on out to infinity. And then for the next one, it is a parenthesis at negative 20, and you go on out to infinity. Okay, so each of those bracket notation situations, they are not over an interval in the beginning and ending of an interval sense, but rather over an infinite distance. Let's try one with the beginning and ending. Go ahead. Express in both interval and bracket notation. Okay, so the bounded interval goes from 2 to 4. So look, it's always the same in the middle here. The less than or equal to, the n, the less than or equal to. The or equal to can change, but the less than, the n, and the less than always stay the same. If the circles are filled in, we add an or equal to underneath. So that would be n is bounded by 2 and 4, or 2 is less than or equal to n, which is less than or equal to 4. And if I do it in bracket notation, it's a bracket 2 comma bracket 4. Okay, all right. So now, next up, slope and y-intercept. Remember, the general equation of a line is y equals mx plus b, and you must get it into y equals form. If it's not in y equals form, then you're not going to get it right, unless they happen to give it to you that way. But if you don't do manipulations that you need to do to make it say y equals, you will not get it right. So go ahead. For these three, let's find out what m and b are. Go ahead. For each of those, find the slope and the y-intercept. Okay. Now, for the first one, it doesn't say y equals yet, so I have to divide everything by 4. The slope is 3/4. The y-intercept is negative 2, right? We would divide everything by 4. Slope is 3/4. Y-intercept's negative 2. Next one, it is in y equals form, so the slope is right where it ought to be. It's negative 2/3, and the y-intercept is negative 3. For the next one, y equals x, this could be a little bit tricky until you get, a chance to really think about it. The slope is the number in front of x. There's nothing written there, but if there's nothing in front of an x, we always assume it's 1 because there is one x there. And then the y-intercept is 0 because in order to be equal to this, you have to do plus 0. So the slope is 1, y-intercept is 0. All right, let's see you do some graphing here. First, you're going to graph 5y equals negative x plus 20. We're actually going to do two lines at the same time, simultaneous solution graphically. Let's have you start with this. I'll put the answer up in a few seconds of my time. You, of course, are doing stop and start. Okay, so it says 5y equals, we don't want that, so we're going to divide everything by 5. That gives me y equals negative 1x over 5. You may not write the 1, plus 4. So the slope is negative 1/5, the y-intercept is 4. This is the green line. Go up to 4 touch, down 1 over 5, down 1 over 5, and connect the dot. Okay, so pretty straightforward by this point. I mean, we've done two dozen of these. You should be pretty comfortable. Okay, next up, y equals x minus 2. This will be the blue line, and it's already in y equals form, so we know the slope is 1 and the y-intercept is negative 2. So I begin at negative 2 with the blue line. There's my negative 2, and then the slope is 1, so it's up 1 over 1, up 1 over 1. And I could do another up 1 over 1, but just to show you, I'm going to do an up 3 over 3. Oh, that's a great point. That point is a point right there that's on both of these lines. Remember, from a theory or conceptual point of view, the green line is the picture of every point that checks or satisfies or works in the green equation. The blue line is the picture of every line that every point that checks or works in or satisfies the blue equation. So the one point where they cross, the one point that has both green and blue on it, is the only point where it satisfies both equations simultaneously, which means it is the simultaneous solution. And we just mark that coordinate down, 5, 3. Okay? All right. Time for you to graph this one. Go ahead, make sure you say make sure you see that it says y equals. Okay, add 3 to both sides. Y equals negative 2x plus 3. Slope is negative 2. Y-intercept is 3. This is the green line. Begin at 3. Down 2 over 1. Down 2 over 1. And connect the dot. Your next line is 2y equals x minus 4. Go ahead, solve for y. Okay, to solve for y on this guy, we've got to divide everything by 2. So I get y equals 1/2 x minus 2, so the y-intercept is 1/2. And, I'm sorry, the y-intercept is negative 2, and the slope is 1/2. So I begin at negative 2 with the blue line. Then I go up 1 over 2, up 1 over 2, up 1 over 2. There is my connected dotted line. I actually should have put 1 on top of the green point, but oh well. Still works out the same either way. That one point right here is the only point that satisfies both the green and the blue equations. It will check in both, and that is the point 2, negative 1. If you checked it, it would work. Okay, so there's 2 good examples of simultaneous graphing with all different varieties in there. Now, oh, look at that. I forgot to animate this guy. So what I'm going to do now is just leave this on here, talk through it a little bit, and make sure you can get it. Okay, so 3x plus y equals 9, x minus y is negative 1. I already have these paired up. So 3x and 1x is 4x, 9 and negative 1 make 8, divided by 4, x is 2. I could proceed like that because I saw that the y's were matched up, opposite signs and same numbers of them. I can substitute in either equation to follow this up. I used the bottom equation, though I would actually have preferred the top. X minus y is negative 1. Substituting in a 2 for x. 2 minus y is negative 1. Subtracting the 2. Negative y is negative 3. Divide by negative 1. Or if the negative y is negative 3, then positive y is positive 3. Y is 3. And here's my check where I plug in the solutions and work them out. Okay. In summary, pair up a variable to eliminate. In this case, it was y. Solve for the other one. We were able to, once eliminated, figure out that x was 2. So I substituted to find the eliminated variable. That was done. Then I have to go back and check. So I plugged in the 2 for x in either equation and found out that y was equal to 3. Okay, let's try another one. Now, while you're working on this, you should do stop and start. I'm just going to correct the animations in the Okay. Let me get this checked out here, and we'll go back to doing the slideshow from this slide here, I believe. Okay. Okay, so we want to solve for x and y on this guy. In case you haven't stopped yet to work the whole problem out, I'm going to just give you a second to pause this video. Okay. So what we notice and focus in on is the x's and y's are lined up. That's really good. The equals are lined up. The numbers are lined up. That says go with the elimination method. The problem is I don't have the y's paired up. So we're going to take the coefficient of the bottom where the signs are opposite, the 2, put that up top, and then the one on top, 3, and put it on the bottom. So distributing the 2, I get 8x plus 6y is negative 2. Distributing the 3, 9x minus 6y is 36. Now my y's match up. This is perfect. Altogether I have 17 x's and I have 34. Dividing by 17 and I get x is 2. Booyah! Now I got to go back and figure out the value for y. I can use either equation, but I prefer the top one because it's positive y's. So I don't know why. Oh, I know why. Because I put it in the wrong slide. All right, I know for correcting purposes. I'll go back and correct the other one later. So 4x plus 3y is negative 1. Plugging in the 2 that I got for x, 4 times 2 is 8, plus 3y is negative 1. Subtracting the 8, 3y is negative 9. Dividing by 3, y is negative 3. And it's going to repeat this again because I did the second set of animations to the wrong slides. But I can correct that in a couple of moments for tomorrow. Here's my check if I want to check. Substituting in a 2 for x and a negative 3 for y. 8 minus 9 is negative 1. Yep, it is. And 6 plus 6 is 12. It is. Very good. Here's our summary. Match the quantity of a variable, like finding the least common denominator. If that doesn't work, take the bottom coefficient, put it in the use it as a multiple for the top, and likewise the top coefficient for the bottom. And everything else is the same. Okay, so now we have word problem. Numbers changed from last time. Go ahead. Okay. 3 donuts and a coffee are $4.50, so 3D plus C is $4.50. 7D plus 3C is $11.50. Now it's just a matter of getting down to usual, business as usual. Notice, of course, that we're going to get rid of the C's, and one of them has to be negated, so I get opposite signs. So I'm going to multiply the top one by negative 3. The bottom one stays the same. Negative 9D plus minus 3C is negative 13.50. 7D and 3C is 11.50. Negative 2D is negative $2. Dividing D is $1. Next up, where are we here? Okay, I got to substitute the D back into either equation. The first one sure looks simpler. So 3 times $1 is $3. Subtracting that, and a cup of coffee is $1.50. All right, so there we have that set on. That's the elimination technique. Pretty straightforward. Let's try the substitution technique. Notice here it's not x's over x's and then y's over y's. We've got one equal sign here, the other equal sign not lined up with it. So that tells me that I should do substitution. The other thing is, if you wanted to look at it just at the second line, it says x equals, which means you can do a substitution for x. So go ahead, solve that. Okay. So I want to substitute for x because it says x equals the y minus 4. So I'm not going to put an x there anymore. I'm going to put a y minus 4, and then everything will be in terms of y. So 2, and then I put parentheses because I'm not putting an x there. Instead, I'm putting what x is equal to, the value of x. Remember, we could trade $1 for 4 quarters because the value of $1 is 4 quarters. Well, according to this, the value of an x is a y minus 4. So I substitute in a y minus 4 plus 5y equals 13. Distributing the 2, 2y minus 8 plus 5y is 13. That's 7y minus 8 is 13, adding the 8. 7y is 21. Dividing by 7, y is 3. The sweet thing about these substitution problems, there's two really sweet things. First off, when we do the first step, it looks very much like what we have been doing for weeks now in class. Second thing is it's really easy to solve for the missing variable. Just substitute in the 3 you found for y, and x is going to equal -1. Okay? I didn't check. I should have. I didn't. Sorry. There's Springsteen on Broadway right there. You know, back when Springsteen was on Broadway, the big play was Hamilton. And I forget, it goes something like this. I'm not sure the exact amounts, but I am sure of the general concept. Hamilton, which was doing more shows per week because they had certain days where they did a matinee and an evening show. I think it was Hamilton was pulling in $2.5 million a week, and Springsteen was pulling in $3 million a week, and it was just him. So he was making an enormous amount of money. I got to tell you, I'm a little disappointed with Bruce. I paid $500 a ticket to go see him on Broadway. This is not something I would normally do, but I was retiring. I had a few extra dollars, and I really wanted to take my son to see this, so I did. When we had very good seats, but it was a small theater. I think the theater held under 900 people, and you know, you could hear his voice plain as day. It was really, really, really nice. I saw him in 2016 at MetLife, and I want to say it was like $150 a ticket or $125 a ticket. And he's going out on tour, and I had a friend of mine from Albany call me up and say, "Hey Bob, come on up, let's go to the Bruce show up at Albany." And the cheapest ticket that I could find was in the upper deck, and they wanted $325 for that ticket. I said, "That's insane." Then I had a friend from Georgia call me up and say, "Hey Bob, listen, there's a fly fishing show in Georgia, in Atlanta." He said, "Come down, you can stay at my place, we'll do the fly fishing show together, and we'll go to, we'll go see Springsteen the night before because he's playing the night before the show." I said, "Hey, that sounds pretty cool." And I looked up the prices, and his cheapest price there was for upper deck was $275. And I don't usually go to the upper deck. I usually go to the pit right in front of the stage. So last time I went, it was $150 for the pit. This time they started at $900 for the pit. That's insanity. I can't afford that kind of money. So Bruce, who's supposed to be the champion of the working man, charging that kind of money, I don't know. I'm a little disappointed in Bruce these days. So maybe we'll blame it all on inflation. Due to inflation, a theater now charges $15 for every adult ticket, a lot less than Bruce, and $9 for every child ticket. The theater sold 181 tickets. First show of the new release. The total money collected from ticket sales was $2,271. Write a system of equations that can be used, and then find the number of adult and child tickets. Go ahead, stop and start. You know how this works. Okay. So, first it's $15 for an adult ticket, so that's 15A, and it's $9 for every child ticket, so that's 9C. And the question is, if every adult ticket's $15 and every child ticket's $9, how much money do they take in? And it says that the money collected, the total money from ticket sales, was $2,271, so that's what it equals. And in my experience, students will write that equation pretty quickly. They'll get that. The next one is the one that can be challenging because they don't come right out and say it. I mean, if they said to you, the total number of adult tickets sold plus the total number of child tickets sold was 181, people would know to write A plus C is 181. But they're kind of subtle about it. They say the theater sold 181 tickets, and you, in your mind, must take that step that says, oh, well, there's only two kinds of tickets. There's adult and child, so A plus C has to be 181. To solve it, I'm going to distribute -9 across the bottom. That gives me 6a is 642, dividing, and I get a is 107. So there's 107 adult tickets sold. And then we're going to find the child tickets. 107 plus the children equals 181. Subtracting 107, child tickets is 74. What's an elimination for when to use, or a theory as to when to use elimination and substitution? If everything is lined up, if I've got x's over x's, y's over y's, equals over equals, numbers over numbers, and of course it could be letters other than x and y, as long as it's like over like, you're looking at elimination. Okay, focusing in on those equal signs and that the variables align. If the equal signs do not align, if anything is kind of disjointed about it, or you could look at it as it says one variable is in terms of the other variable, that says to you to go to substitution. Okay, so those are the two techniques that we've learned to solve algebraically, and the whole key is, I think that each individual technique is pretty easy. You just have to apply the right technique at the right time. All right.